Hello everyone. 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 Yes, we are fixing this soon, no problem. Yes, we are fixing this soon, no problem. Yes, we are fixing this soon, no problem. So now, today is the class on important formulas. Okay, so welcome to this Gear Up JE session. So important formulas. Today is the class on important formulas. Okay, welcome to this Gear Up JE session. So important formulas. Okay, so good evening to all. Yes, so I welcome you all to this session. Okay, so hello everyone. So now we will discuss some of the important formulas of the subject. Today we will be discussing this with the subject of SOM. Okay, the basic we will discuss today. And good evening to all. Okay, so from SOM we will be discussing it today. That is, first of all, let us see the basics of SOM. We have the first formula regarding your factor of safety. What is your factor of safety given by? Okay, so factor of safety is given by your failure stress over permissible stress. Okay, failure stress over permissible stress. Clear? This is the first formula that we are discussing today. That is the failure stress over permissible stress given by factor of safety. Okay, this failure stress, we have the failure stress for different, this factor of safety is used to find out the permissible stress from the failure stress. Failure stress can be for different sort of materials, it could be different. Okay, for the ductile material, in the case of static loading. Okay, in the case of static loading, this failure stress is given by SYT, and that is also when your yielding is not allowed. Basically, yielding is allowed, you should say that the permanent deformation is not allowed. Okay, permanent deformation is not allowed, then SYT is there. When permanent deformation, or you can say, or yielding is not allowed. Okay, for the ductile material, in the case of ductile material, when permanent deformation is allowed, or if we have the brittle material, then we use the ultimate stress that is given by SUT. Okay, and if we have the case of dynamic loading, you can say the fluctuating or fatigue loading, in that case we use this failure stress as your endurance limit. Clear? So this is the everything about this formula for the factor of safety. Clear? Yes or no? Clear? Next we see the next formula is of related to this only, this is margin of safety. Margin of safety given by m is equal to n minus 1. Okay, n minus 1. N is your factor of safety. Factor of safety is generally taken greater than 1. So when n is greater than 1, this m will be greater than 0. If n is equal to 1, then this m margin of safety will become equal to 0. Clear? Okay. Is it okay everyone with these two formulas? Now we move on to the third formula, which is important for this, is stress. Stress is given by force upon area. Force upon area. This is though the internal resisting force per unit area, having the unit of Newton per meter or Newton per mm square or Newton per meter square. Clear? This is your stress, force per unit area, though it is an internal resisting force per unit area. Clear? Now we see the next formula for this, that is your strain. Okay, strain. Or you can say it's a normal strain we are talking about. So normal strain is basically of three types. Either it's a longitudinal or it's a lateral strain. Lateral strain is also known as your transverse strain, or it's a volumetric strain. So for these all three types of strains, we have the formula as change in dimensions over original dimension. Okay, change in dimension over original dimension. This change can be positive. That case it is called as a tensile strain. If it is negative, it is called as a compressive strain. Clear? Is it clear? Compressive strain or tensile strain? Okay, then we talk about another formula, that is of shear strain. What is shear strain? See, shear strain is nothing but, suppose this is a surface, on this a block is kept. We apply this force, that is your shear force, because it is acting along the plane, so it will become a shear force. So according to this, when this force will be applied, so this surface will become somewhat like this. So this perpendicular will become somewhat this phi. So this phi is only known as your shear strain. It is denoted by gamma, and this is nothing but equal to phi. This is your shear strain. Clear? Is it okay? This is your shear strain. Okay. Now we talk about the elastic constants. The first elastic constant we have is your Young's modulus. Young's modulus or Young's modulus of elasticity. Young's modulus of elasticity. Young's modulus of elasticity is given by E. This is equal to your normal stress, or you can say, because this is your, yes, normal stress, not shear stress, it's normal stress over longitudinal strain. This is your Young's modulus. Clear? Then if we talk about another modulus, that is your shear modulus given by G. This is equal to shear stress, that is shown by tau, divided by shear strain, that is given by gamma. Clear? Shear modulus, shear stress over shear strain. Then you have third modulus, that is your bulk modulus. Bulk modulus is given by K. This is equal to normal stress over volumetric strain. So this is denoted by sigma, this is denoted by epsilon V. So this is here, this is given by this is given by epsilon. Clear? So this is your bulk modulus. Then we have one more thing, that is known as Poisson's ratio. Poisson's ratio denoted by mu. This is given by minus of lateral strain over longitudinal strain. Lateral strain over longitudinal strain. Lateral strain means that strain which is taking, longitudinal strain means that strain which is taking place in the direction of loading, okay, and lateral strain means any strain in the, any change in the dimension in any direction opposite other than that. In the direction of loading, the strain is known as longitudinal. In other directions, it is known as lateral strain. So, minus of lateral over longitudinal is given by Poisson's ratio, and the value of Poisson's ratio lie between 0 and half. Okay. Then the relations between these, Young's modulus, shear modulus, bulk modulus using your Poisson's ratio is simply E equal to 2G 1 plus mu. This is the relation between Young's modulus and shear modulus, or E equal to 3K 1 minus 2 mu, relation between elastic modulus and bulk modulus, okay. And the relation between all three, removing the Poisson's ratio, is E equal to 9 kg over 3K plus G. Either you can remember this formula directly, or what you can do, from here you can find out the value of mu as, what will be the value of mu? E over 2G minus 1, and substitute this value of mu here, you will get this value as this. That is E equal to 9 kg over 3K plus G. Clear? Is this formula clear? Okay. Basically, I will be taking only the formulas for this stress strain only. Okay. I am not going to complete the whole SOM here. Only stress strain I am going to talk. Okay. Or basically, I can take a few more, but not many. Correct? Then if we say the expression for, what is the expression for triaxial loading of volumetric strain under triaxial loading? So you can put that as, I can just do one derivation here, expression for volumetric strain under triaxial loading. Okay. So suppose there is a component, a 3D component I am drawing. Clear? This is having the length L, this is the breadth B, this is the thickness T. Clear? Length L, thickness B, breadth B, thickness T. And let us say that these are the directions X, Y and Z. So if this is the load that is acting here, Px, Py and Pz. Okay. So stress in x direction will be given by force upon its area, that is Px over Bt. Sigma y will be given by Py over, this is L, this is B, so Lb, and sigma y z is given by Pz over Lt. Clear? So now in these directions, these will be your stress, and whatever will be the strains, that will be the longitudinal strain. That means any strain in this direction. Okay, let me draw that table for you first. Okay, this you know, sigma y equal to Py over Lb and sigma z is equal to Pz over Lt. Clear? Now see. See, if I talk about, load here, and if we talk about strain in these directions, okay. Let us say that this is x direction, this is y direction, and this is z direction. Okay. In x direction, due to this load Px, in the x direction the strain will be how much? Strain is, you know, from the formula this, that is sigma x, sigma upon epsilon. So this is a strain. So strain will be given by sigma over E. So in the x direction, due to the load Px, this will be simply sigma x over E. But other directions will become the transverse for this. For transverse for this, and we know mu is equal to minus of lateral over longitudinal. Correct? So if we need to find out this lateral or transverse one, we have to just multiply this value, that is the longitudinal strain into the Poisson's ratio and minus of that. So this will be minus mu this will be minus mu sigma x e. Clear? Then similarly, if we say for py this will be your longitudinal, that is sigma y by e will be longitudinal, and others will be your lateral, here as well, here as well. Okay, and the last one for pz, this will be your longitudinal, that is sigma z by e. This will be again mu sigma z by e, and this will be mu sigma z by e. They will all act as lateral. Correct? Okay, so in the directions, now if we see in the directions of x, what are the total strains that are in the direction of x? So that is epsilon x is given by sigma x by e minus mu sigma y by e minus mu sigma z by e. Clear? So if we take 1 by e common from here, we will have sigma x minus mu times sigma y plus sigma z. Clear? Similarly, this is epsilon x. Okay, this is epsilon x. If we talk about epsilon y, it will be 1 by e sigma y minus mu times sigma x plus sigma z. Clear? And if we talk about epsilon z, it will be 1 by e z minus mu times x plus y. Clear? Then the volumetric strain is equal to what? Volumetric strain is equal to epsilon x plus epsilon y plus epsilon z. So if we will add up all these, we will have the relation as 1 minus 2 mu by e sigma x plus sigma y plus sigma z. Clear? Then there can be different conditions for this. The conditions can be, your volumetric strain can be 0, your epsilon v can be 0 when there are two cases, either when your mu is equal to half or the summation of stresses on three perpendicular planes becomes equal to 0. That is sigma x plus sigma y plus sigma z becomes equal to 0, or this value of Poisson's ratio becomes equal to half, that is its maximum value. In that case, your volumetric strain becomes 0. And the last case is, if it is a case of a hydrostatic state of stress. Hydrostatic state of stress, that means your all these stresses are same. Sigma x plus sigma y equal to sigma z, that is equal to sigma. So in that case, your volumetric strain will be given by 1 minus 2 mu by e into 3 sigma. And one more case is there, that if it's a case of uniaxial loading. If it's a case of uniaxial loading, that means sigma 1, or you can say sigma x is equal to sigma and sigma y equal to sigma z equal to 0. So in that case, volumetric strain will be given by 1 minus 2 this into sigma. Clear? And if it's a biaxial loading case, if it's a biaxial case, then sigma x will be there, sigma y will be there, and sigma z will be equal to 0. They will all be present. They will basically not be equal to 0. So in this case, your volumetric strain will be given by 1 minus 2 mu by e sigma x plus sigma y. Clear? Is it okay, everyone? So these are basically some of the formulas, very important formulas from the topic of stress, strain, okay, and the subject of strength of materials. Clear, everyone? So I hope you enjoyed this session. There are very number of formulas which are there in this subject of strength of materials. I am not going to discuss each and every formula here, because I come here every week discussing the formulas and all. So I will be discussing them slowly and gradually for each and every topic, okay, till this plan, the Gear Up JE 2.0 plan goes, okay. So CBT1 expected cutoff, ऐसे नहीं बता सकते, it is not easy to tell this way because it depends upon many other factors, okay, the number of students that have appeared from a particular zone and the cutoff and the vacancies that are available in a particular zone. So it's not that much correct to comment upon that thing here, okay. So keep preparing, just watch these videos, share them with your friends and colleagues, okay. So see you in the next session of Gear Up JE 2.0. Thank you and have a nice day. Keep preparing with Gradeup to score better. Thank you and have a nice day.